Welcome to today's video. We are going to take a look at the concepts of concavity and the second derivative. Above we have the definition for inflection points and where we are concave and concave down. So let's just remind ourselves of this before we go into the example. So given a function f of x where f prime of x and f double prime of x exist, we can say that the function f of x will have an inflection point when f double prime is equal to 0. F of x will be concave up when f double prime is greater than 0. And f of x will be concave down when f double prime is less than 0. So to start, let's take a look at question A. This is going to be where the function is increasing, and we're going to take a look at the graph and identify an interval where it is increasing. So we can see that the graph starts in a decreasing fashion and then reaches some critical point here close to -3 and starts to increase in between those points. So let's just take this value as -3 if we think that critical point is about -3, and we can see that there's another critical point here that reaches a local maximum, say about 0.5 or a half. So the first interval we can write down here is we're going to be increasing from -3 up to a half. If we take a look at the rest of the graph, we also have a second interval where we're increasing, which would be from 3 to infinity. So we can say union that first interval from 3 up to positive infinity. So those are two increasing portions of our function. That's where my first derivative, remember, is positive. So f prime is greater than 0 on those intervals. Let's take a look at where our function is decreasing. We start our function in a decreasing fashion. We notice from negative infinity all the way to this first local minimum value at -3. And we can also see that we'll decrease on another interval here between those local maximums and local minimums. So from 0.5 all the way up to +3 would be two places where our function is decreasing. In other words, my f prime of x is less than 0. My derivative is less than 0 when I am decreasing. Question C says, where will f prime of x be equal to 0? Well, we've defined where our function, our derivative function, is greater than 0 and less than 0. Now we can take a look at, in other words, the critical points where our function is equal to 0. And those points would be coming where we have a flat tangent. And that would happen at 3 points. First at x is equal to -3, at x equals a half, and at x equals 3. Again, this is points where we have a 0 tangent slope. Question D and E start to go into the concept of concavity. In other words, we're considering the second derivative in these questions. So let's consider the second derivative in each of these questions. Where is the function concave up? Well, concave up means that my second derivative, f double prime, is going to be greater than 0. In other words, I'm going to have a kind of upward curvature to my function. If I take a look at where I'm going to have some upward curvature, notice that in the first portion of my function, I go down, minimum, and back up. In this first section of the function, I can say that I'm going to be concave up. My function itself is opening upwards. The curvature is facing up. And so we can take a look at where this would be concave up. We could say from negative infinity all the way to, we can say maybe this point, say at negative 1.5. And we'll notice that we'll be concave down for a region here where my curvature changes from up to down. And maybe we can put in a value of maybe 1.5, about where this marker is, to change our concavity again. So notice we will be concave up again over this region of positive 1.5 up to positive infinity. So we can union those two intervals together to find two intervals where we're concave up in those green regions. This leaves us one interval where we are going to be concave down. So concave down again means that our second derivative is less than 0. And so we'll take a look at those. That would be the inner interval here, negative 1.5 to 1.5, highlighted right here. Finally, we can take a look at, again, these inflection points where my f double prime is equal to 0. And we identified these approximately to be at the points at x equals negative 1.5 and 1.5. In our next video, we will take a look at these specific examples, G through I, to take a look at where we have a combination of a first and second derivative, either positive or negative.